Well, hello everyone. Welcome to this track. Welcome to this talk. I think this is probably the last live presentation of the day. And this presentation, I'm delighted to say, is by Dr. Ulrich Paetzold. He's a professor at KIT, Karlsruhe Institute of Technology. And he'll be telling us today more about novel materials and processes for perovskite-based tandem PVs. Before we start, just a couple of notices. Don't forget about the Christmas quiz. So if you visit the exhibitor booths, you can find the technical characters hidden in there. And if you find where they've been hidden, we will send you a Christmas hamper, a basket of goods to your house before Christmas. And also after this session, there is a small networking, round in the lounge. So please do join us then. The stage is now yours, Dr. Paetzold. You have about 20 minutes. 2 minutes before the end, I will come in to give you kind of a notice and the usual notice to the audience. Don't forget to ask your questions. We will ask all the questions today live and we'll discuss them. So thanks a lot, and the stage is yours.
Thank you very much for the kind introduction. It's a pleasure to be here today and talk about our research here at KIT, which is on novel materials and processes for perovskite-based tandem photovoltaics. So quickly, an introduction. Who are we? Who is KIT? So the Karlsruhe Institute of Technology is located here at the west-south of Germany in Karlsruhe. And we are unique on a German landscape in a sense that we combine two things, which is a state university as well as a Helmholtz Research Center. And that gives us the joy of combining, on the one hand side, the bright minds of the university, as we like to say, with the good infrastructure of Helmholtz. Our labs here are all set up to research perovskite photovoltaics, perovskite single junction photovoltaics, but also perovskite tandem photovoltaics. We've got upscaling labs where we then collaborate with industry partners who we also invite to join in and test their processes and devices. So what are we active in terms of technology? What we focus on the one hand side, we're developing perovskite-based tandem photovoltaics themselves. In particular, we focus on the top cell, the perovskite cell. And then we have a focus in our research on scalable perovskite solar modules, and eventually a smaller focus also on building integrated photovoltaics, vehicle integrated photovoltaics, which I will be talking a bit less today, all with the ingredients of the perovskite solar cell. If I say we, I'm talking about the Task Force Perovskite Photovoltaics. This is a cross-university collaboration here. We join forces by a couple of research groups. This gives us critical mass. So at the moment, we are around 27 PhDs and postdocs, and we need that to run then the technology platforms that are important for industry collaborations. So some time ago were asked to define a mission, and our mission is in line what we believe is the entry of perovskite photovoltaics into the market, which is in particular perovskite-based tandem photovoltaics, and there our mission is to advance the stability and scalability above 33%. What is it, or what is the technology that we're talking about? We talk about tandem photovoltaics. Now my slides are hanging, I'm sorry. I've got a technical issue here on my end. I'm sorry for that.
Yeah, your slides.
I have no idea where this comes from. This wasn't like this before.
Maybe
give me a second. Okay, the next slide appeared. So the perovskite-based tandem device combines a perovskite top solar cell with a silicon or CIGS bottom solar cell. And the idea of this concept is that we harvest the high energy photons in the wide bandgap perovskite top cell, and that we harvest the low energy photons in the silicon or CIGS bottom solar cell. And in this combination, this can be done